Hi everyone. In this session, we are going to see about Internet of Things. I am Keetiga A, Assistant Professor, Department of Information Technology, Erode Engineering College. So, first of all, we are going to see about IoT protocols and smart objects. So let us see what is an Internet of Things. Let us look closely at our mobile device which contains GPS tracking, mobile gyroscope, adaptive brightness, voice direction, phase direction, etc. These components have their own individual features, but what about if these all communicate with each other to provide a better environment? For example, the phone brightness is adjusted based on my GPS location or my direction. Connecting everyday things embedded with electronic software and sensors to internet enabling to collect and exchange data without human interaction called as Internet of Things. So in IoT protocols and smart objects, protocol standardization for IoT efforts M2M and WSN protocols, SCADA and RFID protocols, issues with IoT standardization, unified data standards, protocols, IEEE 802.15.4, BAC Net Protocol, Modbus, KNX, ZigBee, Network Layer, and APS Layer, and security. So when it comes to smart objects, the things in IoT, sensors, actuators, and smart objects, sensor networks, connectivity, connecting smart objects. So the term things in the Internet of Things refers to anything and everything in day-to-day life which is accessed or connected through the internet. IoT is an advanced automation and analytic systems which deals with artificial intelligence, sensor, networking, electronic, cloud messaging, etc. to deliver complete systems for the product or services. The systems created by IoT has greater transparency, control and performance. As we have a platform such as a cloud that contains all the data through which we connect all the things around us. For example, a house where we connect our home appliances such as air conditioner, light, etc. through each other, and all these things are managed at the same platform. Since we have a platform, we can connect a car, track its fuel meter, speed level, and also track the location of the car. So, when it comes to protocol standardization, standardization is key to achieving universally accepted specifications and protocols for true interoperability between devices and applications. The use of standards ensures interoperable and cost effective solutions. These pictures tells about the components of IoT implementations, which are sensors, standards, intelligent analysis, intelligent actions, networks. An IoT network is a group of hardware, including sensors, gadgets, appliances, and software, that interact with one another and share data and information without the need for human interaction. Businesses may now gather new insights from devices through IoT networks thanks to cloud and edge computing capabilities. Organizations may now monitor environmental, geospatial, and atmospheric variables in real time because of this bridging of the digital and physical worlds. Businesses can quickly respond to the environmental changes when combined with automation, resulting in less downtime, more significant insights, and increased productivity. So, how does an IoT network work? For example, for let us take IoT sensors. Small, low-cost sensors are used by IoT networks to gather data about the surroundings. For instance, farmers employ IoT sensors to track moisture levels, while industrial facilities utilize the same sensors to track pipe pressure. IoT sensors provide a wide range of configurations options and can track hundreds of distinct changes. So there are many types of IoT networks. For example, cellular network, Wi-Fi network, local and personal area networks, low power wide area networks, which is in short LPWAN, and mesh networks, and that's all. So let us see about sensors. Sensors in IoT are used for sensing things and devices, etc. A device that provides a usable output in responsible to a specified measurement. The sensor attains a physical parameter and converts it into a single suitable for processing the characteristics of any device or material to detect the presence of a particular physical quantity. The output of the sensor is a signal which is converted to a human readable form like changes in characteristics, changes in resistance, capacitance, and impedance, etc. There are two types of characteristics in sensors used in IoT. They are static and dynamic. So now let us see about the standards. The use of standards in IoT are it ensures the interoperable and cost-effective solutions, open up opportunities in new areas, and allows the market to reach its full potential. The more things are connected, the greater the security risk. So security standards are also needed to protect the individuals, businesses, and governments which will use the IoT. So, when it comes to intelligent analysis, the emergence of Internet of Things based applications has increased the challenges faced in intelligent data analytics in such constrained IoT devices. The huge volume of collected data cannot be efficiently analyzed in IoT devices due to their limited resources. Therefore, there is an increasing need for advanced learning and data mining techniques to efficiently and effectively understand, learn, and reason with these large volumes of information. So now let us say about the intelligent actions. The requirement of high data rates, low latency, efficient use of spectrum, and coexistence of different network technologies are major considerations in IoT based fifth generation networks. To achieve the above requirements, incorporation of artificial intelligence is required to make efficient decisions based on the massive data generated by the large number of IoT devices. AI methods analyze the data to extract the patterns and make sense of the data to prescribe action to the end devices. So, the most common protocols in IoT are AMQP, short for Advanced Message Queuing Protocol. AMQP is an open standard protocol used for more message oriented middleware. Bluetooth and BLE. Bluetooth is a short range wireless technology that uses short wavelength, ultra high frequency radio waves. Then cellular, COAP, DDS, LoRa and LoRa WAN, LWM2M, MQTT. Let us see briefly about the AMQP protocol. AMQP stands for Advanced Message Queuing Protocol. AMQP is an open protocol for asynchronous message queuing which has been developed and matured over several years. AMQP is an open standard binary application layer protocol designed for message oriented middleware, that is, AMQP protocol standardizes messaging using producers, brokers, and consumers, and messaging increases loose coupling and scalability. The AMQP was contrived to enable a wide range of applications and systems to work together regardless of their internal design, standardizing enterprise messaging of an industrial scale. AMQP protocol has been selected the OASIS, which is SIS industry standard groups 1 with the invention of moving to becoming an ISO IEC standard. AMQP protocol is almost a complete superset, lacking only explicit protocol support for lost value queues and will messages. However, its deliberate design for extensibility using an IANA-like approach with a discursive approach ensures that such features can be added in a forward compatible widely agreed upon way. So now we are going to see about Bluetooth. We all know about Bluetooth, but in short, let me explain something about the Bluetooth. Bluetooth is universal for short range wireless, voice, and data communication. It is a wireless personal area network technology and is used for exchanging data over smaller distance. This technology was invented by Ericsson in 1994. Bluetooth simply follows the principle of transmitting and receiving data using radio waves. It can be paired with other device which has also Bluetooth, but it should be within the estimated communication range to connect. When two devices start to share data, they form a network called PicoNet, which can further accommodate more than 5 devices. So, Bluetooth IoT devices is a wireless technology protocol that relies on physical proximity to establish connections between devices without the need for a password. Bluetooth IoT applications are remote controls, smart home gadgets, wearables, tracking devices, and keyboards, among others, have been designed to reduce the stress and financial costs associated with consumers having to change batteries regularly owing to the usage of energy saving Bluetooth programs and energy harvesting models. Bluetooth IoT applications are used in industrial and enterprise solutions. Bluetooth in IoT will make people's lives and duties easier by automating various activities through a variety of Bluetooth IoT initiatives. COAP, a customary client server IoT protocol. It enables clients to make requests for web transfers as per the need of the hour. On the other hand, it also lets supporting servers to respond to arriving requests. In summary, devices nodes in the IoT systems ecosystem are enabled to interact over through COAP only. And the COP protocol stands for Constrained Application Protocol. Is a web-based protocol that has been specifically designed to connect small, semi-intelligent devices to the Internet of Things. So let us see about the DDS protocol in IoT. It is an IoT protocol developed by Object Management Group for machine-to-machine communication. It uses a publish-subscribe methodology for exchanging data. It uses multicasting to bring high quality of servers to the applications. In the DDS protocol, there are two layers named DCPS and DLRA. Now, LoRa protocol. LoRa is a physical layer protocol that uses split spectrum modulation and supports long range communication at the cost of a narrow bandwidth. It uses a narrow band waveform with a central frequency to send data, which makes it robust to interference. Now, MQTT protocol in IoT. MQTT is a standards based messaging protocol or set of rules used for machine to machine communication. Smart sensors, wearables, and other Internet of Things devices typically have to transmit and receive data over a resource constrained network with limited bandwidth. So now let us move on to the next slide, which is effort in IoT. IoT protocols ensure that information from one device or sensor gets read and understood by another device, a gateway, a service. Different IoT protocols have been designed and optimized for different scenarios and usage. So, in Internet Protocol is a set of rules that dictates how data gets sent into the internet. IoT protocols ensure that information from one device or sensors get read. As IoT devices interact and communicate with each other, they can automate the tasks, helping to improve the quality of businesses' service and reducing the need for human intervention. By reducing the human effort, it saves a lot of our time. The next slide is about M2M and WSN protocols. M2M and WSN protocols, machine to machine, is direct communication between devices using any communications channel, including wired and wireless. So, what is machine to machine protocol? So, it is a broad label that can be used to describe any technology that enables network devices to exchange information and perform actions without the manual assistance of humans. Artificial intelligence and machine learning facilitate the communication between systems, allowing them to make their own autonomous choices. Machine to machine technology was first adopted in manufacturing and industrial settings where other technologies such as SCADA and remote monitoring helped remotely manage and control data from equipment. M2M has since found applications in other sectors such as healthcare, business, and insurance. M2M is also the foundation for the Internet of Things. The main purpose of machine to machine technology is to tap into sensor data and transmit it to a network. Unlike SCADA or other remote monitoring tools, M2M systems often use public networks and access methods, for example, cellular or Ethernet, to make it more cost effective. The main components of an M2M system includes sensors, RFID, a Wi-Fi cellular, A Wi-Fi or a cellular communication links an autonomic computing software programmed to help a network device interpret data and make decisions. These machine-to-machine applications translate the data, which can trigger pre-programmed automated actions. One of the most well-known types of machine-to-machine communication is telemetry, which has been used since the early part of the last century to transmit operational data. Pioneers in telemetrics first used telephone lines and later radio waves to transmit performance measurements gathered from monitoring instruments in remote locations. And the and this is about machine-to-machine technology. So let us see about the WSN protocols, which is a wireless sensor networks. An IoT wireless sensor network refers to a group of spatially dispersed and dedicated sensors for monitoring and recording the physical conditions of the environment and collectively pass on such data through a wireless network to an internet-based location. WSNs measures the environmental conditions like temperature, sound, pollution level, humidity, wind speed and direction, pressure, etc. The 9 Libelium wireless sensor network models available from same 9 provide the same quality and accuracy as traditional wired measurement systems but with increased flexibility, more than 60 sensor types to choose, and lower cost and the ability to create smart WSN systems with cloud and wireless sensor networking services. So M2M with Internet protocols could be considered a subset of the Internet of Things and understood from a more vertical and closed point of view. So some of the most widely used protocols in M2M or IoT are MQTT, COAP. These two are seen before, and OMA, LW, M2M, etc. These protocols specifically target low power devices which have to conserve power so that they can operate for a long time. In these given protocols, MQTT and COAP are seen before. The new one is OMA, LW, M2M. Let us see about it. OMA Lightweight M2M is a protocol from the Open Mobile Alliance for Machine to Machine or Internet of Things device management and service enablement. The LWM2M standard defines application layer communication protocol between an LWM2M server and an LWM2M client, which is located in an IoT device. It is used for design to reduce power and data usage for low power devices, which are limited in processing power and bandwidth. The protocol is ideal when people or devices are a long way from power and need to use battery powered local devices, have a SIM card, and no power cards. So, when it comes to the WSN protocol, the data sensed by the sensor nodes in a wireless sensor network is typically forwarded to the base station that connects the sensor network with the other networks where the data is collected, analyzed, and some action is taken accordingly. The key difference between IoT and M2M is that IoT connects any device to the internet for better performance, and M2M is the connection of two or more than two devices with the internet for data sharing and analytics. In WSN protocol, the WSN is deployed over a region where some phenomenon is to be monitored. A military example is the use of sensors to detect enemy intrusion. A civilian example is the geofencing of gas or oil pipelines. Now let us see about the example of an M2M connection, which is a machine-to-machine connection. An example of an M2M connection in other sectors is a vending machine. It automatically sends out information about its inventory to dispatchers. Another typical example is an ATM, which sends information when it's low on cash to the authorities on its own. M2M technology involves the automatic and streamlined sharing of information between two or more separate devices. Common examples include smart home meters, vehicle telemetry services, asset tracking, wearable technologies, and automated supply chain management. So now let us see about the benefits or advantages of machine to machine, which is a M2M communication. It is easy to roll out and maintain. It is available with fixed and mobile networks both indoors and outdoors. It offers higher range, minimum latency, higher throughput, and consumes less energy. It enables communication of smart devices without any human intervention. The security and privacy issues in IoT networks are resolved by using M2M communication facility, and large protection, data collection, data processing is possible in M2M communication. So, drawbacks of MTM communication. Security and large scale data collection is a significant concern. It was designed and optimized to be used for only a small number of connected devices. Interoperability between cloud and IoT devices in such networks is often limited. And the use of cloud computing in M2M means dependence on others, which could limit flexibility and innovation. Security and ownership of data is a big concern. MTM communication requires availability of constant internet connection with reasonable speed. So now let us see the applications of machine to machine communication. There are many applications in MTM communications such as manufacturing, remote monitoring, billing, robotics, security, automotive, logistics of fleet management, traffic control, telemedicine, utilities, industry. And now let us see briefly about some of the applications. First of all, we can see about the manufacturing in M2M applications. In M2M, manufacturing is utilized for communicating multiple variables such as product stocking, machine repair, etc. through remote monitoring. IoT uses techniques such as M2M, SCADA, RFID, and machine learning algorithms to provide optimized solutions. Let us see about telemedicine in M2M application. M2M communication refers to the automated exchange of data between devices between each other or from a device to a central system. M2M applications in medical technology include, for example, some ECG devices or emergency vehicles. Without human intervention, these transmit data so that information is available on demand on another end device. M10 solutions are now also increasingly being used in home care. These technologies transmit data from measuring devices on the patient, for example, and thus help with patient monitoring from a distance. The data is usually transmitted via the internet. For this purpose, the medical devices can be connected by cable, for example, or they can be equipped with M2M SIM cards that enable wireless data transmission. Especially with M2M SIM cards for telemedicine applications, the expansion of 5G will play a major role. With 5G, it will be possible in future to exchange high data volumes almost in real time. So, some of the advantages of M2M medical technology in healthcare are regardless of whether the connection is made by cable or M2M SIM card. In medical technology, the communication of devices brings considerable advantages. For one thing, the automated exchange of data from machine to machine is always faster and more effective as well as less error prone than the manual transfer of information. For example, the networking of surgical instruments are devices on boards that would otherwise have to be monitored by personnel. But telehealth is not always about speed. Telemedicine applications have been driven primarily by situations where doctor or specialist and patient are physically separated. These includes residents of remote towns as well as the space travel with astronauts in space and researchers on an expedition in the Arctic. So let us see the selected advantages of mission to mission for telehealth at a glance. Accelerated emergency communication and increased flexibility for medical staff, locating patients in emergency, more efficient organization and management, example of free beds, cost reductions through time savings, faster access to patient data, patient monitoring for more safety, reduction of error sources through increased automation. So now let us move on to the next slide. The next slide is about SCADA and RFID protocols. The SCADA protocols is designed to provide secure and reliable communication between the central control unit and the remote devices. Some commonly used SCADA protocols includes Modbus, DNP3 and OPC. RFID is a wireless communication protocol that is used for identifying and tracking objects or people. So, what is SCADA? SCADA stands for Supervisory Control and Data Acquisition. It is a computer system designed to gather and analyze real time data. It is used to control and monitor the equipment and manufacturing processes in various industries in different fields such as water and waste control, telecommunications, oil and gas refining, power generation, and transportation. SCADA systems were used for the first time in the 1960s. It controls the functioning of equipment involved in manufacturing, production, fabrication, development, and more. It is also used for infrastructural processes such as gas and oil distribution, electrical power distribution, water distribution, and more. Thus, it has reduced human intervention to a great extent. Furthermore, it is also used by industrial organizations to accomplish the following tasks: to control industrial processes locally as well as at remote locations, to monitor, gather, and process real-time data, to interact with devices such as sensors, valves, motors, pumps, and more using human-machine interface software. It comprises both software and hardware. Different industries have different requirements, so there are maybe some differences in their SCADA systems, which is a SADA systems, but still some features are common for all, such as graphic interface, process mimic, real-time checking, alarm system, data acquisition, data analysis, report generator. So let us take an example of a leak on a pipeline. When a pipeline starts leaking, the SCADA system gathers information and forwards it to a central site and thus alerts the home station about the leak. It also analyzes the situation such as how big is the leak and how much water is being released. The SCADA system can be very simple, such as which are used to monitor the environmental conditions of a small office, building, or complex, or can be very advanced, such as which are used to monitor the activity in a nuclear power plant or the activity of a municipal water system. The SCADA system feeds data to a graphical user interface or dashboard. That data is then monitored by humans. IoT devices connected to the network are monitored. Collected data is generally stored in a cloud server. SCADA sensors that detect small changes in the environment, including temperature and sound. Modbus and DNP3 are two of the most common protocols used in SCADA networks. Modbus is open source and 80 to 90% of plant devices such as inverters, trackers, etc. speak Modbus protocol. DNP3 is a newer protocol that is primarily used to communicate between different substations devices in the SCADA system. So the current standard used in RFID is the EPC Global Class 1 Gen 2 protocol. This is an arbitration oriented protocol used in every commercial leader, also included in ISO 19006. So let us see about the applications of SCADA. SCADA systems are widely used in the following types: oil and gas, pipeline monitoring and control, plant or factory automation, water and wastewater, water treatment centers and distribution. Utilities, electrical power distribution from gas fired, coal, nuclear, agriculture or irrigation, manufacturing, food and beverage, and pharmaceutical. Let us see a short note about radio frequency identification. Radio frequency identification is short of RFID, of wireless communication that incorporates the use of electromagnetic or electrostatic coupling in the radio frequency portion of the electromagnetic spectrum to uniquely identify an object, animal, or person. It uses radio frequency to search, identify, track, and communicate with teams and people. It is a method that is used to track or identify an object by radio transmission uses the over the web. Data digitally encoded in an RFID tag which might be read by the reader. This device works as a tag or label during which data read from tags that are stored in the database through the reader as compared to the traditional barcodes and QR codes. It is often read outside the road of either passive or active RFID. There are many kinds of RFID, each with different properties, but perhaps The most fascinating aspect of RFID technology is that most RFID tags have neither an electric plug nor a battery. Instead, all of the energy needed to operate them is supplied in the form of radio waves by RFID readers. This technology is called passive RFID to distinguish it from the less common active RFID in which there is a power source on the tag. So now let us move on to the next slide, which is about issues with IoT standardization. Security. As many new nodes and IoT devices are added to networks, there will invariably be increasing the security gaps, opportunities, and target for attacks. And then connectivity, compatibility and standards, technology integration, and intelligent analysis. So it is about in this slide, these challenges have impacted its development. So security and privacy concerns. One of the biggest challenges facing the world of IoT is security and privacy. Compatibility issue, which is another challenges facing the world of IoT is compatibility. And then cost, regulation, and slow adoption. So let us see about unified data standards. Unified data is when a company merges its many fragmented data sources into one single central view. Unified data provides a more complete and accurate picture of a company's data, but unifying the data is far from simple. Unified data is the collection of all internal and external data representing the entire scope of an enterprise's information needs. IoT industry can lead to reduced efficiency, increased costs, and a slower rate of information. Now let us see about the advantages of unified data standards. The best benefits of unified and structured data are the opportunity to easily incorporate data sets collected by other companies, the possibility of being able to benchmark a much more comprehensive analysis of the context and more informed decisions, more sophisticated algorithms, and greater data consistency. Let us see about the benefits of unified storage. Unified storage frees administrators from having to manage multiple sets of tools and pools of disparate storage. And it is also have the benefits of cost savings, and also it reduces the hardware to maintain. It is less hardware to maintain. Unified storage offers cost savings by enabling adopters to consolidate storage over an existing network. Now let us move on to the next slide, which is about IoT protocols. COAP, MQTT, HTTP. This slide is about IEEE 802.15.4. IEEE 802.15.4 is a wireless networking standard developed for low power, low data rate applications in personal area networks for IoT, embedded systems, and wireless sensor networks. It is known for its low power consumption, extended battery life, mesh networking capabilities, and cost effectiveness. WPAN or Bluetooth. Task Group 1 is based on Bluetooth technology. It defines physical layer and media access control specification for wireless connectivity with fixed, portable, and moving devices within or entering personal operating space. Data rates of 250 kbps, 40 kbps, and 20 kbps. Two addressing modes, 16-bit short and 64-bit IEEE addressing. Support for critical latency devices such as joysticks and CSMA/CA channel access. It also enables the automatic network establishment by the coordinator, fully handshaked protocol for transfer reliability. The importance of IEEE 802.15.4. IEEE standard 802.15.4 intends to offer the fundamental low-end network layers of a type of wireless personal area network which focuses on low cost, low speed, ubiquitous communication between devices. The advantages of IEEE 802.15.4. 4 is the standard which is the basis for many low power wireless connectivity solutions including Zigbee, 6LoWPAN, Thread, and many more. It is a standard that was developed to provide a framework and lower layers in the OSI model for low cost, low power wireless connectivity networks. So now let us move on to the next slide, which is about BAC net protocol. The BAC net protocol defines a number of services that are used to communicate between building devices. The protocol services include whose, I am, who has, I have, which are used for device and object discovery. Services such as read property and write property are used for data sharing. BAC works by dividing the problem of interoperability into three distinct areas and by defining methods and standards for implementing each. All information within an interoperable BAC net device is modeled in terms of one or more information objects. The use of BAC net protocol includes the following. It is used in HVAC applications, the fire control, lighting control, security, alarm, and interfacing to utility companies. This protocol was particularly designed for building automation as well as control applications. BAC Net Protocol was developed by a committee named ASHIAE or the American Society of Heating, Refrigerating, and Air Conditioning Engineers in 1987. The main motto of this committee is to make a protocol that would provide systems from various manufacturers to communicate together in a pleasant way. So, this protocol is a registered brand of ASHIAE. Since the time protocol was developed, it is undergoing continuous changes with an open agreement procedure so that all interested parties are welcome to participate with no fees. And it is a data communication protocol that is used to build an automated control network is known as BAC net or Building Automation Control Network. This data communication protocol is both an ISO and ANSI standard used for interoperability between cooperating building automation devices. BACnet protocol includes a set of rules for governing the data exchange on a computer network that simply covers all from what type of cable to utilize to form a particular command or request in a normal way. And now let us see the advantages of BAC net protocol. BACnet protocol offers two-way high-performance communication for the building. This protocol makes it possible to integrate products from different manufacturers into one project. It also offers modularity in the building and facilitates its operation. Now let us see about the Modbus. Modbus is a serial communication protocol that was developed by Modicon. It was first published in 1979 for the use with the company's programmable logic controllers. In basic terms, it is one of the methods used for information transmission over serial lines between electronic devices. With the rise of the Internet of Things, the Modbus protocol has gained significant relevance. Modbus, especially Modbus TCP/IP, is used to enable communication between IoT devices, sensors, and controllers over Internet networks. Its simplicity and wide support make it a common choice for IoT communications. Now let us see about the advantages of Modbus. Based on master-slave architecture, Modbus offers high operational flexibility. Its serial RTU mode speeds up data exchanges with its 8-bit encoding while allowing the connection of 247 peripherals over a distance of 1200 meters. Now let us see the features of Modbus. The one of the feature of Modbus is client-server relationship and the message architecture and the data storage architecture on client devices. The physical characteristics of the network connecting the devices. Modbus is restricted to addressing 247 devices on one data link, limiting the number of field devices connected to a master station. KNX IoT is an inclusive technology supporting a diverse range of interactions between KNX and third devices. One of the most popular services for IoT is that of IFTTT, if this then that, which allows you to control your KNX system via our support home systems such as Alexa or Google Home. So KNX is a communication protocol developed for widely used in home and building automation. It is a standardized and OSI based network communication protocol. KNX can be installed into new or existing developments, be it a new build or retrofit project, residential or commercial. Wired and wireless IP and powerline communication mediums, it is possible to use the system within any building types administered by the KNX Association. Now, let us move on to the next slide, which is about the ZigBee. Zigbee is a standards based wireless technology developed to enable low cost, low power wireless machine to machine and Internet of Things network. Zigbee is for low data rate, low power applications. And this is about Zigbee. So it is designed to meet low power and low data rate applications and is developed under IEEE 802.15.4 standard by the Zigbee appliance. Typically, Zigbee is used in establishing a smart home for devices from different manufacturers to communicate with each other to enable automation. A typical example is when you have a Zigbee enabled light bulb and a Zigbee enabled light switch and you want the light switch to control the light bulb. Zigbee, the two devices, even if they are from different manufacturers, speak a common language so there is no barrier to communication. So now let us see about the advantages of Zigbee. Support for multiple network topologies such as point-to-point, low duty cycle provides long battery life, low latency, direct sequences, spread spectrum, up to 65,000 nodes per network. 128-bit AES encryption for secure data connections and collision avoidance retries and acknowledgements. Now let us see about the network layer. The primary function of the network layer is to enable different networks to be interconnected. It does this by forwarding packets to network routers which rely on algorithms to determine the best paths for data to travel. The network layer is the part of the internet communications process where these communications or connections occur by sending packets of data back and forth between different networks. So let us see about the APS layer. The application layer acts as an interface between end user and IoT. The user can utilize the data and manage the device through the set of applications that runs in this layer. This IoT layer can be tailored according to the requirement and it is possible to run a high level smart application in this layer. And this is about APL layer. In this APL layer, application framework, Zigbee device objects and network layer. And now let us see about the security. IoT security is the act of securing internet devices and the networks they are connected to from threats and breaches by protecting, identifying and monitoring risk all while helping fix vulnerabilities from a range of devices that can pose security risks to your business. In addition, network security users needs to protect their devices against unauthorized access and potential exploitation. Nano agents provide on device security for IoT devices. Firmware assessment. Firmware security starts with assessing the firmware of a protected IoT device. Internet of Things devices are computerized internet connected objects such as networked security cameras, smart refrigerators, and Wi Fi capable automobiles. IoT security is the process of securing these devices and ensuring they do not introduce threats into a network. IoT security risks. Internet of Things privacy is the special considerations required to protect the information of individuals from exposure in the IoT environment in which almost any physical or logical entity or object can be given a unique identifier and the ability to communicate autonomously over the internet or similar network. And this picture displays the types of IoT security attacks: communication attacks, attacks on the device software, physical attacks, lifestyle attacks. And let us see about the smart objects. Smart objects, also known as intelligent objects, are objects that are equipped with positioning and communication technologies and are integrated into a communication network, the so called Internet of Things. And this picture is about smart objects, which displays the identification and data storage, sensors and actuators, electronic data processing and decision making, communication and network capability. So next slide is about the smart objects, which is already seen. We have two types of smart objects. One is embedded and one is linked. While both are useful and have some unique functions, they can also sometimes create limitations in creating a smart object. The concept smart for a smart physical object simply means that it is active, digital, network, can operate to some extent autonomously, is configurable and which is reconfigurable and has local control of the resources it needs such as energy, data storage, etc. And next is about the world of IoT is the network of interconnected heterogeneous objects such as smart devices, smart objects, sensors, actuators, RFID, embedded computers, etc. Uniquely addressable and based on standard communication protocols. And it displays the some of the smart objects which are data collection devices, RFID systems, digital signage, smart machinery, phones and tablets, security systems, home automation, medical devices. Smart object saves the source image data. It can transform and manipulate your layer without fear of jeopardizing the image's quality or data. This allows you to scale, distort, warp, rotate, or otherwise transform a layer within your project and keep the original image data untouched. In addition, the Internet of Things describes the network of physical objects, things that are embedded with sensors, software and other technologies for the purpose of connecting and exchanging data with other devices and systems over the Internet. So, and the Internet of Things is a technology that allows us to add a device to an inert object, for example, vehicles, plant electronic systems, roofs, lighting, etc., that can measure environmental parameters, generate associated data, and transmit them through a communication network. And sensors and smart objects. IoT sensors are pieces of hardware that detect changes in an environment and collect data. They are the pieces of an IoT ecosystem that bridge the digital world to the physical world. Deploying sensors and sensing technologies has multiple benefits, including predictive and preventive maintenance. They not only ensure that measurement data is transmitted faster but also increase accuracy, thereby improving process control and enhancing asset health. So, let us see about the benefits of IoT in smart objects: real time assert or resource visibility, reduced costs, and then improved operation efficiency, data driven insights for quick decision making, end to end remote monitoring and management of assets or resources, real time predictive and prescriptive insights, improve end customer experiences. So, IoT actuators enable a physical action based on data that originates with one or more sensors. The conversion of sensor data to activity flows follows this sequence. Sensors detect an event in the physical environment. Another form of a transducer can operate in the opposite direction of sensors. It can convert an electrical impulse into a physical phenomenon. For example, an electric motor, a pneumatic system, and a hydraulic system are a few types of actuators in IoT. The control system can be a human, a fixed mechanical or electronic system, or even software based, say a printer driver or a robot control system. Examples of actuators include electric motors, step motors, electroactive polymers, screw jacks, servo mechanism, solenoids, and hydraulic cylinders. So now let us move on to the next slide, which is about sensor networks. An IoT, Internet of Things wireless sensor network, refers to a group of spatially dispersed and dedicated sensors for monitoring and recording the physical conditions of the environment, and collectively pass on such data through a wireless network to an internet-based location. Sensor networks. The sensor is the bond of a sensor network node. Examples of sensors include temperature sensor, accelerometers, infrared detectors, proximity sensors, and motion detectors. And in this picture, it displays the sensor nodes gateway, which is connected to the internet and also connected to the management node. Sensor nodes and gateways grouply called as sensor field. Sensor network topologies. Let us see about the topologies in sensors. Sensor topologies can also be described as having either a flat or hierarchical architecture. In a flat peer-to-peer architecture, every node in the network has some computational and communicational capabilities. So let us see about this picture. In this picture, there are meshed wireless sensor domain and meshed aggregator router domain and the internet, which is interconnected with each other. And sensor network. A sensor is a device that measures the physical input from its environment and converts it into data that can be interpreted by either a human or a machine. Most sensors are electronic, the data is converted into electronic data, but some of them are more simple, such as glass thermometer, which presents visual data. So now let us see about the connecting smart objects. The Internet of Things describes a vision in which everyday objects are connected to the internet, be identified and communicate with other devices. These objects are typically referred to as smart objects. The aim is to digitalizing the applications and process to make them easier and more efficient. And now let us see about the examples of connecting smart objects, which are connected watch, connected thermostat, connected light bulb, smart refrigerator, voice assistant. And this is all about Internet of Things. Thank you. Let us end this session.